We're going to be talking about algebraic proofs. An algebraic proof is where you're going to prove every step of an algebraic equation using a property. So we have reflexive property, symmetric property. These are outlined based on these pictures. You'll also find them in your textbook. Okay, so the first one we're going to look at is this equation right here. Okay, so we know that your very first step is your equation. This is given. You didn't do anything to get there, so you would just write given. From here, to get from step 1 to step 2, well, normally you would think they distributed, but they did not distribute the 2. What they've done here is divided this whole equation by 2, or the whole expression by 2, and the whole right side by 2, so that these 2's canceled out. They were left with x plus 3 equals 8 divided by 2 is 4. Since they divided by the same thing on both sides, this would be your division property of equality. Okay, from here, they subtracted 3 on both sides to get x by itself, which means this answer is actually wrong. 4 minus 3 is 1, and that would be your subtraction property of equality. Okay, from here, we're going to look at a second example. The first step they've done is they gave you the equation. So again, your first step is always going to be given. Okay? The second step, they're left with 2x plus 6 equals 10. Well, what they've done is they multiplied both sides of the equation by our denominator of 5, so that these 5's canceled out, so they divide out to 1. You're left with 2x plus 6 equals 2 times 5 is 10. So that would be your multiplication property of equality. You cannot just write multiplication, because we want to show that it's the property of equality to show that when you multiply the same thing on both sides of an equation, your equation still equals itself. From here, they subtracted 6 on both sides and got 2x equals 4, so that would be your subtraction property of equality. Okay, the last step is they divided by 2 on both sides of your equation, which would be your division property of equality. Oops. Okay, so you've just finished 2 proofs here. Now, they won't always give you the statements in a typical proof, but the hardest part is coming up with the reasons. So if you can come up with the reasons, and essentially we're justifying our steps every step of the way. So this next one, they've asked us to fill in. They gave us the equation, they told us the given and the proof, that the end that we're supposed to get to. So based on this given, that's where we started with. They always put the given first, and we know that it is given. Our goal is to get W by itself. Well, the first thing we're going to do is subtract 2L on both sides. So you're left with P minus 2L equals 2W. Well, if you subtracted the same thing on both sides, that's your subtraction property of equality. Okay, from here, they divided by 2 on both sides to end up with P minus 2L all divided by 2 equals W. Well, if they divided on both sides, that would be your division property of equality. Okay, so this next step, they gave you the circumference formula. Okay, so again, that was our given, so our reason would just be given. And then our goal is to solve it for r. solve for the radius. So we're going to divide by 2 pi on both sides, which would give us c over 2 pi equals, the 2 pi's cancel out and you're left with r. That's what we're trying to prove. And that would be by your division property of equality. Okay, so let's look at this next one. From here, again, this time we're trying to get our L by itself. So the first thing we need to do, well, they gave us the equation, so that would be your given. Now you can subtract b on both sides. So s minus b equals 1/2 perimeter times slant height. Okay, so that we subtracted b on both sides would be your subtraction property of equality. Okay, then we want to get rid of that 1/2, so I'm going to go ahead and multiply by 2 over 1 by the reciprocal on both sides. So now we have 2 times s minus b equals your perimeter times your slant height. Now I'm not going to distribute it because in our answer it's not distributed. So if I distribute it now, it will just confuse me. So this would be your multiplication property of equality. Okay, from here to get the L by itself, we're going to divide by p, and 2 times s minus b, all divided by p equals L by division property of equality. Now we're going to take that algebra and put it into geometry, okay? So we're given this line and they've specified segment NO, okay? And they're using the segment addition postulate that says NO equals NM plus MO. So they said the whole thing is 4x minus 4 equals 2x plus 3x minus 9. Well, what they've done is they started off with the statement, okay? We know this, NO equals NM plus MO, based on our segment addition postulate. And the reason is because the picture was what was given to us this time. So now, based on the picture, we can state this. From here, we substituted in these values for NO, NM, and MO. So our next step would be substitution, property of equality. Okay. From here, what they did is they combined like terms, 2x and 3x to give you 5x. So we could just put combine like terms. Okay. From there, they subtracted 4x on both sides of the equation. So that would be your subtraction property of equality. Okay. Then they added 9 to both sides, which would be your addition property of equality. From here, you would know that since 5 equals x, you could plug it back in to figure out the length of NM, MO, and NO. Why don't you try example 7 on your own, and I'll post the answers at the end of this video. From here, we're going to look at the properties and give a statement for each, okay? So if PQ plus ST equals ST plus RS, then based on the subtraction property of equality, then we could subtract ST from both sides, and say that PQ equals RS. And again, since we're using equals, it's the length of, so there's no segment bar on top. On number 9, it asks us to use the division property of equality. So if 3 times the measure of angle A equals 90, if we divide by 3 on both sides, then the measure of angle A would equal 30 degrees. Number 10 asks us to use the subtraction property of equality. Well, measure of angle 1 plus 45 equals measure of angle 2 plus 45. We could subtract 45 on both sides, and then the measure of angle 1 equals the measure of angle 2. And the last one, addition property of equality, if MN equals RS and AB equals CD, then we could say MN plus AB equals RS plus CD, because essentially this AB and CD, since they're the same, we're adding the same thing to both sides. So if MN equaled RS initially, then when we add the same thing to both sides, they're still going to be equal.